Assalamu alaikum. Welcome to the next topic, that is the capacitance of a 3-core cable. Earlier we have derived the formula for the capacitance of single core cable. As we know, or we can simply guess, that the capacitance of the cables will be much higher than the capacitance of the overhead lines. There are usually three reasons for this case. Since the conductors of uh, the cables are very close to each other, and also the sheath, which is at earth potential, is also close to the conductors. And the third reason is that the dielectric that we have used has a permittivity higher than that of the air. These three reasons will make the capacitance of the cable more as compared to overhead lines. It can be seen from this simple equation. We know that this is the capacitance of any material or a three-phase line with having some permittivity ER. As we have derived this formula for a capacitance of a cable in presence of earth, that will be equal to 2 pi epsilon 0 epsilon r ln of d by r minus ln of d12 d23 d31 divided by d11 d22 d33. This we have derived in the second chapter. Since permittivity is higher, it results in the higher value of the C, because we are using the dialect of higher permittivity. Since D is less, that is the distance between the conductors is less, that means since D is less, this term will be lower, and overall this term will be higher. So this is the second reason. And the third reason is that since this sheet is at earth potential, that means the earth presence of the earth will be very close to the conductors as compared to the overhead line, and which makes this term to be very significant, and this also results in the decrease of this overall uh, denominator, which results in the increase in the capacitance. Reasons these three reasons uh, will increase the capacitance of the underground cable. Now this is the equivalent circuit of an three-phase underground cable, where these 3 points represent the conductors, and this capacitance is the capacitance between conductor and sheath. This is also the capacitance between conductor and sheath. This is the capacitor of the conductor and sheath. This represents the capacitance between the two conductors, like this. So it forms a delta in between the cable. So we can convert this into equivalent star. You will see that when this delta is converted to star, this CS is the capacitance of the cable to sheath, and this CC is the capacitance between the two conductors. When we convert this into equivalent star, this capacitance, its equivalent value will be 3 times of this C times CC. C is the core to core capacitance. Usually we know that when we do the star delta transformation, this, let us say we will calculate this resistance equivalent impedance, it will be equal to Z2 into Z1, Z1 into Z3, that is these two impedances, divided by Z1 plus Z2 plus Z3. If they are all same, like here all the capacitance or impedance are same, it will be equal to Z square by 3Z, that will be equal to Z by 3. So the impedance of equivalent impedance in star of the delta will be 1 by 3 times that of equivalent impedance in the delta. But here we have to calculate the capacitance, that will be equal to this Z will be equal to 1 by omega C, that is 1 by 3 omega C. Omega will take out, it will be equal to 3C. That means equivalent capacitance will be 3 times C, because it is actually not impedance. This capacitance will directly not come into impedance, it will come into admittance. Admittance will increase in case of this star, but in case of this impedance, it will decrease. Now one more important point here, you need to be very careful. Here it is a star point, so mentally it means this point is at ground, this point is at ground, or we can say that this point and this point, this whole circle, that is sheath, will be at the ground potential. will be at the ground potential. When this is ground potential, that means this point is, we can say, mentally connected to this point. So when we see that this point is connected to this point, so we can calculate the per phase capacitance. Per phase capacitance will be actually the equivalent capacitance between this point and this point, isn't it? Since the potential of sheet is 0, this point of potential will be 0. This point is mentally, we can say, connected to this. That means these two capacitance will be in parallel, and Cn will be the per phase capacitance, sometimes denoted by C naught, will be equal to this 3 times Cc plus Cs, because it is actually, mentally we can say, they are connected in parallel. This is 3 times Cc, this is Cs. That is what I have written over here. So if V phase is given as the phase voltage, so charging current can be easily calculated. That is equal to 2 pi f, that is omega c into V phase. We can calculate the charging current. But it's not, we cannot directly calculate the Cc or Cs. We need to perform certain measurements or certain tests. In that case, then we can calculate this Cc and Cs, and finally this Cm. So there are two tests of actually separating this Cs and Cc. The first one is, what we do in this case, we connect all the conductors to each other, or we can say we tie them together. Capacitance between three core bunched together, and the earth sheet. What we do, we connect all the three conductors together through a wire, and then we calculate or we measure the capacitance between the conductor and sheath. You will see that these points will be at one point. They are connected. That means these points are connected to each other. That means this capacitance has one point connected to this capacitance, and this capacitance has the same point connected to the other point of the capacitance. Their next point or next leg is connected together through the sheath. We can say equivalently these three capacitors are parallel to each other. When we get the C, let us say this is Ci. When we get the Ci, total capacitance is actually the parallel combination of these three capacitors. That means this Ci will be equal to 3 times Cs. Cs plus Cs plus Cs. Cs, Cs, Cs. So here we can easily calculate the value of Cs. Cs will be equal to this Ci divided by 3. So next one is, what we do, we calculate the capacitance between the two cores or lines shorted with the sheath. What does this mean? You see it here. Where first connect any two cores to the sheath like this. We have connect them to the sheath. That means we are shorting these two capacitances, these Cs and Cs. We are shorting, and measure the capacitance between the remaining conductor and sheath. The remaining conductor is only this conductor, and then we measure the conductor between this and this. Okay, and this will be the C, let us say, second. From here also you can see that this point, one of this point, and this point is connected through sheath, and this point is common to the three capacitors. These here also, all the three capacitors will be in parallel. That is, this Cs is here, I have kept it here, this Cc is here, and this Cc is here. So this C second double I will be equal to Cs plus 2I Cc. So we can now calculate this Cs and Cc. Now 3 I have actually added 1 Cc and subtracted 1 Cc. It will be equal to 3 times Cc plus Cs. So this is equal to C naught or Cn minus Cc. So C second will be equal to C naught minus Cc. And we know that from the previous measurement, The C naught will be equal to, not C naught, wait a minute, okay, CS. Here this CS will be equal to C1 by 3 plus twice CC, and this CC can be calculated from here. That will be equal to C2 divided by 2 minus C1 divided by 6. This is the value of the CC, that is the capacitance between the cores. Similarly, total capacitance can be calculated, that is CS plus 3 times CC, that is equal to CS will be equal to CI by 3 plus 3C 2 by 2 multiplied by 3 minus, when we multiply it by 3, 3 1s are 3 2s, it will be equal to minus C by 2. The total capacitance will be then equal to this 3 by 2 C2 minus C1 by 6. In this case we can calculate the capacitance, capacitance of the core and capacitance of the sheath. Thank you.